In this video, I'm going to go over this lab. So you can see here, this is the requirement. Please use a multi debugger to debug victim.exe with a long command line argument. Okay, and so you can see here, this is the code, right? And we have the victim.c here, and this is the combination command. And so here is the code. We have a very simple program here. So we have a function f, which takes one argument string here. And so you can see inside of function f, we declare, a buffer foo, which is 8 bytes. And then we just string copy the argument to this buffer. Then you can see here, because the string copy is really bad and it doesn't check the boundary. So if here the string is very long, we will have the buffer overflow issue. That's why I ask you to enter a very long password. Okay, then in the main function, we just call function f with the command line argument, right? Then we return. Okay, so let's go into our, Windows VM. Then I open this File Explorer. Okay, so I guess the code is within the workshop. Here is the sample code, and I think victim.exe is here. So let's delete it. Okay, let's delete everything here, and we just keep the source code here. So I right click, open it with Notepad++. So this is the code, right? You can see here I have the, command line command to actually compile this program. So I open the command prompt. So I need to go to the right folder, and it's called the workshop, right? And the sample code. So then I right click to compile this victim.c and generate victim.exe. So here, this parameter is to disable, the dynamic base, so that this victim.exe is always loaded to the same location when we run this program. So this is just easier for us to debug the program. Okay, good. So if we come back to here, you see victim.exe appears again. Okay, as we mentioned, so to debug this program, we use IDE freeware here to first locate where the main function is, where the function f is. So I just new and load victim.exe here. Okay, so this is a PE file, so we just click OK, use default assembly parameters. So remember here, we can use a spacebar to get into the text mode. And so this is the code you can see here. So basically the main function starts at this location, and function f starts at this location. Okay, and so this is consistent with the D assembly I shown here, right? So 15AB is where the main function starts. 1590 is where function f starts. So everything looks good. Okay, and so then let's load a multi debugger. Okay, so here we load a multi debugger. Victim.exe is here, open. So here you need to pay attention. We need to enter a long password, right? So here we need to use debug arguments to set the long password. So I really don't care, and I just write a very long password. Okay, doesn't matter how long it is, but it should be very long. Then you can see here it says you have changed the command line argument. If you want that new argument take effect now, you must restart the debugged program. Okay, so let's restart it to click this. So pay attention when you put your mouse to the button here, and then here it shows what it means, right? So here is a restart. Then you can see here the argument is still here. Okay, good. So then we find the 15AB, right? That's where the main function starts. 15AB. Okay, so I already actually set 2 breakpoints here. Okay, very good. So now let's look at the requirement. Okay, so this is the first requirement. Please set a breakpoint at the entry. That is the instruction at the address 0401590 of function f. Good. So okay, so we come back and we already did it. So let me talk out this breakpoint. Okay, so now we only keep one breakpoint. Remember here, this pane is the assembly pane. This is a registers pane. This is the stack pane. So here it shows, what the stack looks like. Okay, so when the program is loaded into, this EMU debugger, then you can see our stack looks like this. Okay, and this shows the values of our registers. So let's look at the requirement. So please provide a screenshot of the stack when victim.exe runs to the breakpoint. Okay, so this is the breakpoint. We just click here, then it will run until it reaches the breakpoint. Okay, so this is what the stack looks like when we reach, the breakpoint, right? The stack. So the stack is shown in this stack pane. So remember, okay? So basically, this is what the stack looks like when we run to this instruction. Remember, this instruction is not run yet, and it will be run next. Okay, and so let's look at the second question here. Please indicate the return address of function f on the stack in the screenshot. So basically, when we come to here, then the ESP, right, the top of the stack, stores the return address of this function f. So basically, here is the top of the stack. The address is 0061FEDC, and at this address of the stack, we have the value of 04015C9. This is the return address. So basically, this return address is stored at this location on the stack. So what is a 04015C9? that is this instruction following what? Following, the function call here, right? So remember, so here is our function call. Okay. And so let me remember this. So basically, the return address is stored at this location. So F's return address is stored at 0061 FEDC, and the value is right. The value is what? 004015C9. 15C9. That is this one. Okay, NOP here. Okay. What is next? What is the stack address at which the return address of a function f is stored? Okay, so this is basically the return address, right? It is stored at this location. So this location has an address of 0061 FEDC. Okay, so that is that answer. Please indicate the argument passed to function f on the stack in the screenshot. Good. So as we know, right, on top of the return address, right, then we have the argument. So that's what we mentioned before you call function. You need to put the argument first before you call that function. So you can see here. So basically, the argument is stored at this location 0061 FEE0, and this is the argument, which is the address of the string. So this is the basically pointed to the command line argument 00AD9B50. So I found out, so every time when you actually run this program, the stack address may be different, so that's okay, but you need to understand what is happening here. Okay, and so let's look at question 2 here. Please set a breakpoint at 401583. 1583 is where? 1583 is here. That's just at string copy function, but the function is not called yet if we actually set a breakpoint here. So good. So let me see what is the requirements here. Okay, good. Please provide a screenshot of the stack when victim.exe runs to the breakpoint. Good. So then we just run it. So now we come to this instruction, but it's not run yet. So, however, here is what the stack looks like. So as we know, right, before you call string copy, you need to provide the arguments to string copy. So you can see here, basically, the source address was first pushed to the stack, then it's a destination address. So as we mentioned, so when you actually call a function, we first push, the later arguments onto the stack first, and then finally we push, the first argument. So that's what happened. Right? Good. Okay. So basically, you can see here. So these are the two arguments for string copy, and you can see here, a Unity debugger is very friendly. It already tells you which one is a destination, which one is a source for string copy. And so let's look at the requirement. Please indicate the argument src of string copy on the stack, please indicate the argument destination of string copy on the stack. So that's what we already did, right? So here is the destination. So what is the destination? It's 666. I'm sorry, 061 FEC8. Right. So this is the destination. Okay. So let me record this. String copies, 2 arguments. Right. The DST, the value is 061 FE what? C8. 061 FEC8, and so the source, you can see this is basically the command line argument, right? Where's 061 FEC8 here. Okay, so basically this is where the buffer foo starts. So what will happen is we are going to copy, right? The string copy, this function will copy the source, this sequence of A's, to this location. Okay, and FEC8, right? And let's look at the requirements. Good. So let's set the breakpoint to here, FEA8. Okay, so then we write. So now we come to here. So let's look at, okay, good. So now we come to here. Please provide a screenshot of the stack when victim exe runs to the breakpoint. So this is what it looks like. So this is basically, you know, what the stack looks like. Okay. Right, and then we come to here, right? Please indicate where F008 starts. So it's very easy to tell because now you can see here all the A's are copied to the destination. Of course, F00 starts at 061 FEC8. Okay, and please indicate where the return address of F is stored on the stack. We already answered this question, right? So please indicate the return address of function F on the stack, right? And so I remember I copied the answer here, right? So here, so the return address is stored as a 61FEDC, 61FEDC. So 61FEDC is here. Okay, so you can see here because we actually provided a very long password. This very long password overrides the return address. Okay, and so let's look at the requirement. Yeah, good. So is the return address changed? Yes, because the long passwords overrides the return address. And the core reason is string copy doesn't check the boundary, it just happily copies everything. So although you can see here in the C code, right, you know, we declare F00 only has 8 bytes, but string copy is stupid. It doesn't check the boundary, so it just copies whatever in this string to this buffer. Okay, so this is buffer overflow vulnerability. So what happens when victim.exe finishes running within emu debugger? So what really happens is so when we write, so basically when the function returns, it will actually try to run the instruction at the return address. However, in this case, you know, the return address becomes 61616161, and it's not valid. So we will have a segmentation fault, means that there's a memory error here. So let's just run it. So you can see here it says access violation when trying to executing the instruction at 61616161 because, right, we overwrote the return address, and so when function f returns, we are going to run the instruction at the return address, which is now 61616161, which is not valid. That's why we have access violation. So let me have a look at this. Yeah, okay, so this is what happens. Okay,